Okay guys, it's me Imad. So today in this video tutorial we will learn about how to use the D flip-flop module or element within the simulide simulator. So how we can use it out? First we will go and we will search in the component section, that where our module is located. So here in the memory section we got our flip-flop D. Click on it and drag it out to the main circuit window. So this is our D flip-flop. Now we have to double click on it. We have to uncheck both of these options. Okay, now we got our simplified form of D flip-flop. Now it has two outputs and one input and one pin for the clock signal. Now how it used to work? If there is any bit applied to this input, that is either 0 or 1, it will be given as it is to this Q output. Let us take an example that 0 has been submitted to the input D. Then whenever our clock signal used to come, that is a rising edge of the clock, then this 0 has been submitted to this output Q. Okay, and after this has been done, if we use to supply any sort of bit, then it is not going to be supplied to the Q. So this concept is actually the concept of memory, that it is in the latch condition now. Okay, and whenever we will get a second pulse of the clock signal, then only the next input will be supplied to this Q. So until the second or next clock pulse, our signal remains, or our bit remains as it is on the Q output. So let's do experimentally. We will go and we will take our fixed voltage power supply. So this is our fixed voltage power supply. This is first and this is second. We need to connect our fixed voltage power supply with that of D and also with the clock signal, like this. And in this clock, this power supply will actually provide 0 or 1, either 0 volt, which will be considered as 0 logic, and plus 5 volt, which is considered as the logic 1. And for output observation, we need an LED. So we can take an LED, click on it and drag it out, like this. Now we will go and we will take our ground. So this is ground, like this. Now, and one more thing, that why we are not using this Q bar, because it is just showing an inverted output of this main output, that is Q. So we are not going to use it out. Now we will run it out. And now, okay, wait, let me see what happened. Okay, now we can see that it is 0. Okay, now we have 0 on the output and 0 on the input. Now we will make our input high, that is 1. Okay, but you can see that the output, that is Q, has remembered its previous stage, that is 0. So 0 is still there on the output. Whenever we will give a clock signal, that is a rising edge, that is plus 5 volt, like this. Now our D input logic has been supplied or passed to this Q output. Okay, and now if we use to change our D, it is not going to work. Okay, until our second clock signal used to come. So now it is 0 on the D And now whenever we will give our clock signal, this 0 on D will be supplied to this Q output. Now we can click on it. Now you can see that our 0, that is input, has been supplied to this Q. And now even if we use to do 0 1 0 1 on the input, it is not going to affect our output. So in this way we can say that our D flip-flop used to work. So hopefully you got the concept. So thanks for visiting our channel and don't forget to subscribe.